Okay, here's a thought. What if making artificial intelligence smarter for really complex jobs like coding actually means making it act, well, more cautiously, almost like a careful human?
Mhm.
And what if getting that kind of nuanced behavior needs a really intricate, maybe even a sort of psychological way of talking to it?
That's a fascinating way to put it, yeah.
Welcome to this deep dive, everyone. Today, we're pulling back the curtain on a pretty interesting strategy for getting top-notch coding work out of AI, specifically models like Claude.
Right, it's not just about getting code spat out passively.
Exactly. It's more like a deliberate, careful investment in quality. We're looking at a method called precision prompting.
Mm.
So we've gathered a bunch of insights and research that describe how this, well, sophisticated and context-heavy approach works.
Yeah, there's quite a bit to it.
Our mission today is to unpack that surprising upfront investment, let's call it the overhead, and figure out why experts seem convinced it's absolutely worth the prize, the better AI performance, especially when the coding gets tough. It's a trade-off, definitely.
Get ready for some maybe aha moments about how humans are essentially prepping these AIs for success.
Priming them in a way.
Right, so you hear precision prompting and maybe you think, okay, efficiency boost, but what our sources are saying is there's this significant overhead right at the start.
That's right. It's definitely an investment. This isn't really for someone just wanting, quick code snippets without much fuss.
Okay.
The core idea is building this very structured, context-rich environment inside the AI's working memory, its context window.
And that involves specific things.
Oh, yeah. It's quite involved. You've got components like a master prompt that sets the AI's main role and rules for the whole session.
Yeah.
Then handover documents, which are basically detailed notes from previous work.
Mm.
And a really critical memory system, which tries to keep relevant knowledge persistent.
Uh-huh.
And all that together, well, it eats up a good chunk of the AI's available context. The estimate is maybe less than 80% is left free after setup, and honestly, that might even be optimistic sometimes. Wow. Okay, so if you're loading it up like that just to get started, what's the immediate practical impact? What can one Claude instance actually do with that remaining context?
Well, because of that initial load, a single Claude instance using this framework can usually only manage, say, one significant refactoring task.
One.
Or maybe a very tightly connected series of smaller code tweaks. But yeah, one main chunk of work before that context window gets really, really stressed.
A refactor being?
Just restructuring existing code to make it better, cleaner, maybe faster, without actually changing what it does on the outside.
Got it. So one substantial refactor. That sounds, I don't know, really limited on the surface. How do they make that productive? It feels like a potential bottleneck.
Yeah, it does seem that way, but here's the clever part. They repurpose the session strategically.
How so?
So once the main goal is done, and importantly, it's been checked and validated by the human operator.
Right. Got to make sure it works.
Exactly. The AI doesn't just stop. Its remaining time and context are used to basically scout ahead. It looks for other potential improvements or problems in the code.
Ah, so it's preparing for the next step.
Precisely. It's acting like a scout for the next AI instance. It identifies things, these are documented, passed on, and it turns what could be wasted time into valuable prep work for the next AI session.
That's smart. Turning a limitation into reconnaissance. Okay, but it still sounds like a hefty investment context time setup. Why bother with this context-heavy, seemingly limited approach? What's the thinking behind it?
Well, it seems to boil down to managing some almost human-like quirks of these powerful AI models.
Human-like quirks in coding AI.
Yeah, it's fascinating. Claude, for instance, is incredibly good at coding, but because it learned from massive amounts of human-written code,
Ah.
it also learned human patterns. And being a prediction engine, it tends to follow the common paths it saw in the training data. That includes, common human coding habits, the good ones, and sometimes the not so good ones, like maybe taking shortcuts or using patterns that aren't always optimal.
Okay, that makes sense. So humans, we take calculated risks, right? We sort of understand the potential downsides. Does the AI have that same kind of nuanced risk sense? Or is that what needs to be added?
That's exactly the point. That's the crucial difference. An AI like Claude doesn't natively have that risk assessment ability. It doesn't inherently fear making a mistake or desire a perfect outcome.
So you have to kind of build it in.
Yes, or at least simulate it. Those equivalents, the fear of failure, the desire to succeed, They have to be carefully built into the instructions through this priming process.
It's not about making it feel emotions.
And no, not at all. It's about crafting the prompts, the instructions, so that the AI prioritizes things like avoiding errors, being thorough, maybe double-checking dependencies over just raw speed or the most common solution.
So you're basically programming in caution.
You're priming it to act as if it understands the consequences of failure. You want it working smart, not just fast, avoiding risks that could mess up the whole project.
And I can see how that caution would be especially useful when you're dealing with massive code bases. How does this help a developer feel more confident there?
Well, yeah, think about it. With a huge project, you can't possibly give the AI access to every single file and just hope it figures out all the connections. That's just not practical.
Right, the context window wouldn't handle it anyway.
Exactly. So instead, this precision prompting approach instills that proactive caution. It encourages the AI to think carefully about any change, to be very aware of what it doesn't know because of context limits.
Which gives the developer more trust.
A much greater degree of confidence, yeah.
Yeah.
The AI is operating with this built-in mindset of being careful and considering potential impacts, not just blindly changing code.
Okay, so bring this all together. What does the actual day-to-day workflow look like? The sources describe this very iterative process, right? Keeping the developer in the loop constantly.
Absolutely. It's a continuous cycle. Let's walk through it.
Please do.
Okay, so step one, the human developer defines the main goal for this particular Claude session. Refactor this module or implement this feature.
Clear objective?
Yep. Then, step two, Claude gets to work and completes that task. Step three, and this is crucial, the developer tests the changes thoroughly, like really tests them in the actual application.
Real world check. Makes sense.
Then, step four, assuming it all worked. The current Claude instance, using its remaining context, starts that scouting mission we talked about, looking for other issues or improvements. The developer reviews these suggestions, gives a thumbs up or thumbs down, essentially signs off on them. Then Claude bundles these approved suggestions into a detailed handover report specifically for the next AI.
In step five?
Step five, the current Claude session ends. Job done, handover prepared.
Okay, and then the loop starts again. You bring in a fresh Claude instance. What's its first job?
Right, a new instance spins up. It gets initialized with that whole standard suite of precision prompts, the master prompt, memory system, all that setup.
Okay.
Then, its first task is actually to review that handover report from the previous AI. It looks at those suggestions.
The ones the developer okayed.
Exactly. If those inherited tasks are pretty straightforward, the AI implements them first. Then it moves on to its own main objective for the session, the one the developer assigned to it.
But what if those inherited tasks aren't simple? What if they're complicated?
Ah, good question. That's where the AI's own assessment comes in. If it looks at those inherited tasks and determines they're complex, it might flag that it doesn't have enough context resources to do both those inherited tasks and its main planned objective for the session.
So it raises a flag, basically. Warning. Might run out of steam here.
Sort of, yeah. It signals a potential context limitation.
So if the AI does that, how does the developer adjust? What's the strategy then? You can't just push ahead.
No, you adapt. This is where that intelligent interaction really shines. If the AI flags context limitations after dealing with the inherited stuff, the session's focus might pivot.
Pivot to what?
Instead of trying to tackle its big main objective and risking, a context meltdown where it loses track of things,
Right.
the session might focus purely on more investigation. The AI would then spend its time analyzing the code base, maybe assessing how hard new ideas would be, the pros and cons of a bigger refactor down the line.
So it provides strategic groundwork instead of risky code changes.
Exactly. It delivers valuable strategic input for the developer, helping plan future sessions, rather than attempting a major coding task it's just not set up for at that moment. It's about getting the most useful output possible from each session, whatever that might be.
It really paints a picture of this continuous cycle, doesn't it? Develop, test, verify, strategically hand off information, proactively look for improvements.
All orchestrated by the human developer.
Yeah, and guided by this really deliberate, almost psychological framework they've built for the AI. It ensures that consistency and quality carry over from one AI instance to the next.
It's quite a system.
This whole deep dive into precision prompting, it really pushes back against the idea of AI as this totally autonomous thing that just works on its own.
Yeah, it's much more managed.
Definitely. It reveals AI In this context, at least, as a highly managed tool, almost psychologically programmed, you could say, and deeply woven into a human-led iterative process.
It's a partnership, really.
It makes you wonder, doesn't it, how much of what we perceive as AI as intelligence is actually just a reflection of how sophisticated we're getting at guiding it, at constraining it in useful ways. What really jumps out at you about this whole approach, something for you listeners to think about too.